Testing sound, testing, testing. Always a good idea to do that because the first time I did it, it didn't work. All right, getting everything set up. Also, sort of vaguely delaying in the hopes that people show up. Let's see here. All right, then. Last time we were working on implementing functions, and I actually committed and pushed. Haven't done much since. This is a test program in the new toy language, TL. Going to need a more sophisticated one soon. Now, one thing I realized from last time is, in fact, there's an operation that needs to be accessed from a couple of different places. And so it probably should be inside of statement list. So we'll put it here. Oh, stupid thing in its inability to handle focus, pointer-based focused. Grr. Sure. So there's some code here. Parse var decal. Parse func declaration, parse func call, parse assignment, parse var decal. So what does parse var decal do? First, it looks for the var keyword and it does a bunch of stuff. But then once it discovers all of this stuff, it goes and finds the enclosing block, and it adds itself. Oh my. It doesn't. This is going to be really tricky. So there are a couple of places where this belongs. Uh, we aren't going to put the one that needs to go here quite yet. There is one that needs to go into the context, and the context is in fact completely private to the parser. I say that there is a parse context and that it's a private class, but other than that, I say nothing about it other than saying that I'm going to be passing in a reference to it. So, hi there. Welcome back to the stream. I'm glad that you found it educational enough that you wanted to come back, or maybe the drone of my voice is so pleasant to listen to while you work that you want to have it on in the background even if you're not really listening to me. I'm not sure which. I hope it's educational, but I'll take the other two. Let's see here. Scope frame, parse context. Oh, what was that task again? I forgot. It's been a while. Okay. Now this is something where I'm going to actually need to have two copies of this side by side because there's two very different parts where I need to be looking. Um, there's no option for copyright. That's kind of annoying. We'll do split down. And then down here, we'll scroll down to, oh, that's right. How did you go about doing it? The recreating your game world. Did any of the advice I offered point you in a helpful direction? So here I want to take this and move it up to here. And so in order to do that, I'm going to have okay. So block. And here I want, huh. Yeah. And here I should use scope decals instead of, just because repeating this is just silly. Okay. And this is at column 89, so it's too long. So we're going to put this down here. Why does it do this? This is kind of weird. All right. There. All right. Let's see here. Let's read what you did. I used a bunch of different tools and resources. Although, of course, anybody who's, well, I don't know. There might be people who are not on Twitch who are watching. I used a bunch of different tools and resources, but I had Nano Banana Pro from Gemini to map out the image, estimate links and everything. Then I learned Blender enough to build out a decent looking castle, used Terrain 3D and Godot to build out the terrain according to those dimensions, textured everything, and then added a buttload of post-processing effects like film grain, weather effects like fog, finally threw in some shadows for the stars. It's not exactly the same, but it's pretty close. It was a journey for sure. I ended up using signals to catch stack overflows. Oh, hi there, Sir Elfman. Well, I'm glad, uh, Z439, that you were able to get the scene that you wanted out of thing. And it looks like you used a good set of tools to do it. Um, Congratulations. What does Windows use? I'm surprised you used I'm surprised you use signals, but I can understand about it being more performant. They probably would be. Vectors, which of course, I'm guessing they named after the vector class was added to C++ because, they had to be confusing. But it's interesting. They called them vectors. Oh, so you use long jump. Did you use long jump inside of a C++ program? I am going to get up for a bit. I want to get something to drink. I'm still technically here, but just, not in front of the camera. Oops. Back. Interesting. Well, that was very clever of you. I actually have a different project where I might have to get that low level in things called POSIX PP, which I have absolutely no intention of ever porting to Windows. Uh, although, and maybe never even porting to BSD or some other Unix. But it will be intended to run on Linux and multiple CPUs, which will mean it is, in fact, specific enough. I do have some inline assembly in there, and that's specific to the platform, that the architecture that Linux is running on. It's basically an attempt to re-implement the C standard library without, or the C++ standard library without the C standard library, and also implement all of the system calls as being inline, which is pretty tricky. Yeah, if you here you can see where my GitHub is. It's POSIX PP instead of CTRE Lexer, if you're curious about it. I've gotten parts of it to work. The real hard part about it has been there's two parts that are hard. First, if you're going to make your inline assembly if you're going to make your inline assembly actually into inline function calls, you have to be extremely careful about memory semantics. You have to make sure that the compiler is well aware this region of memory, I can't like be storing it in registers and stuff. It has to actually make it out into memory before I'm done, right? And the uh, or before I start the system call. And then I have to, any registers that might have been holding this other contents of this other memory region, well, they no longer hold the contents of that memory region anymore. I have to spill, I have to reread anything from that memory region. I can't be, you know, playing tricks behind the backs of anybody for this part. And I have to be specific about memory regions, or all of the not all, but many of the advantages of making the system calls be inline functions are lost, because if you just tell the thing, oh yes, all memory has to look right before this call starts, and all memory has to be considered invalid after this call ends, well, there's little then to distinguish it from a function call. All you're really doing is enabling it to be a little more clever about what registers are going to be used for what, um, to make sure that the values magically show up in the correct registers for the system call instead of whatever registers it was going to use for them. So that's one part that's really tricky, and I haven't really thought about how to do it. I've been thinking that maybe it's a good place for, because there's a way to do it with, if I could have templates that generated inline assembly code, then it wouldn't, it would, there would be some ways to do it programmatically that would work out pretty well. But you can't do that. And so I was thinking that that's actually a good use of an LLM, is basically as a kind of a template expansion mechanism for inline assembly. The other thing that is tricky about it is there's a whole bunch of helper functions that GCC has that are really important. Like add exit is one of them, but there's a bunch of stuff that's set up to make add exit work. And C++, of course, has to make use of all of that stuff because it needs to make sure that all the global destructors get called. Also, the way exception handling works and interacts with the stack, all of that stuff, I have to think that through too. And I've gotten some simple hello world or somewhat more complex examples than that to work. And when compiled with C++, when compiled properly, hello world is incredibly tiny. It's like less than a K in size once it's all linked and everything, because it's just loading up some registers and pointing them at setting them up to point at the right static region of memory, and then executing the syscall instruction. And there you go. Uh, One of the other motivations behind it is there's a there's a thing that C does that is absolutely incredibly awful. It is such a terrible design choice. At the time that C did it, it wasn't as terrible a design choice, but nowadays it's an abysmal design choice, and that is Erno. Erno is terrible. Oh, that is pretty nifty. It is, I would imagine, I have never written a JIT before, but it seems like something that would be difficult to squeeze into 500 kilobytes. Um, anyway, I think Erno is awful. And it's not mandated by the way the system call interface for the kernel works at all. The system call interface for the kernel works by dumping both the return value of the function or the error code into the EAX register or the RAX register. And if it's a negative value in the RAX register, then it's an error. And what negative value it is tells you what error it was. And so, like, the return code is in line with any values you get back from these functions. So I all of my system call wrappers return something like unexpected. And I actually, it's one thing I should do is, now that std unexpected is a part of the standard library, I should make my standard unexpected work exactly the same way as it does. I wrote my own standard unexpected. Um, oh, that's pretty nifty. Is Bohm statically linked or dynamically linked? I have never used it before, so I don't know if it's possible to get BOEM to be dynamically linked and have it work. So, okay, neat. That's pretty good. Um, anyway, the interface that I have in POSIX PP, everything returns the equivalent of C++'s expected, which is the right way. That's the correct way to do error handling, in my opinion. Um, and it completely eliminates erno, which means that you don't no longer like. One of the problems with erno is that it's a thread local variable. Thread local variables tend to be expensive to access, and trying to remember to check it after every call, all of that stuff. Erno is just a terrible design choice nowadays. And so, yeah, that's one other thing that I'm proud of with POSIX PP, and it's a goal is to have much better error handling. Ah, well, that's nice. I have avoided garbage collectors in general, except when I can't, like in Python or Java or Go. Can't use them in Go either. Oh, so what's a tag pointer mean to BOEM? Like, what is it if you're using BOEM with tag pointers? What is that? What is a tag pointer? BOEM is one of those things where I know it exists, but I've never used it. Okay, so this declare var is now in here. Oh, indeed, I can make it constant. It's true. Stupid thing, it does not understand focus follows mouse. It annoys me to no end. Uh, that's a very helpful message, though, that I can make this const. Um, now, the statement list can't be const, but the pointer is const, because the pointer is going to always refer to the same one. This scope decals isn't const because I need to uh, do in place back on it, which was basically definitely a non-const operation. And because scope decals can't be const, that's the reason why curscope can't be const over here, even though the pointer itself is const. In fact, curscope, the pointer, isn't even used after this. I don't believe that it ever appears after this use. But that's a problem for the optimizer to deal with. All right. So now declare var is in here. Okay. And then parse statement. That's the other one that's going to have to do something a little weird. Hmm. The first 16 bits. Don't you mean the I'm a big endian thinker. Um, so the first 16 bits to me means the most significant 16 bits, which works out very poorly for most 64-bit platforms. But the least significant 16 bits can work out just great as long as you're yes. Also, the middle 16 bits works on 64-bit platforms, which is kind of annoying. Um, 16 bits on the left. So the most significant 16 bits. Interesting. That means you have to restore the bits that were there because, yeah, the bits that were there because the CPUs purposefully divide up. My headphones auto turn off every once in a while if they aren't getting any sound to play into my ears. you have to restore the top 16 bits, but because most 64-bit architectures, or the not most, the x86-64, the top 16 bits are going to all be 0 or all be Fs, depending upon the pointer. Like stack pointers are typically the top 16 bits are all Fs, or all ones, and the lower 16 bits for everything else is usually, or the upper 16 bits is usually zeros, or something like that. It's not quite that simple. And so I'm wondering how you, yeah, is this on, I assume you're running it on, because you're running it on Windows, that means you must have it work on an x86-64 platform. So I'm very confused how you're using the most significant 16 bits and actually having that work out right, um, for the tag. Now the middle 16 bits might work. Um, but yeah, interesting. Okay. Oh, okay. So if they're never stack pointers, then you never have to worry about that. Um, and so then you can, okay. And okay, that makes sense. So you know what the upper 16 bits are going to be in all cases and can easily restore them. That means they're probably all zeros. Okay, that makes sense. You're going to end up with some interesting issues if ever you move to ARM, because I don't know that ARM uses the same layout for its pointers. Ah, I see. I don't know enough about ARM to know what MTE is. Also, RISC-V is the up and coming architecture. Oh, so BOEM, because it has explicit support for pointer tagging, that means it can tell you which bits of the pointer are safe to use for a tag. Okay. So you don't have to, it handles the architecture dependence for you. Interesting. What's MTE anyway? Ah, okay. So something that kind of randomizes pointers. Yep. Interesting. All right. So parse statement. That's not the one I care about. Parse sequence. That's the one I care about. And this is the one that creates the scope frame. Um, this is interesting because it turns out that parse sequence, in fact, might not be the best place to create the scope frame. Um, hmm. This is going to be really tricky to work my way around. So the problem here is that here I'm parsing the sequence, right? And sequence means brace delimited thing. Brace, bunch of sequence of statements, and open brace, sequence of statement, close brace. And so the problem here is that actually the function declaration is the start of a scope, not the opening brace of the sequence of statements making up the function. And so that means the creation of the scope frame needs to be decoupled from the parsing of the sequence. Now, scope frame. So scope frame is it's an RAII type thing that exists to right here. Exists to basically push things and pop things off of the scope stack reliably, so that its constructor pushes something onto the scope stack and its destructor pops something from the scope stack. No, I really need to have that's not what I wanted. And I just so here's what we're going to do. We're just going to open the parser in each one of these. Parser.cpp. Where is it? It's not in here. Not in here. Not in here. Ah, there it is. Using an IDE for too long, I forget the structure of my own project. There we go. Now we have two of them. Okay. So scope frame basically exists to push something onto the context stack. And then delete from the context stack when it's done. So let's see here. Where does parse sequence show up? Here at parse top. Anywhere else that it shows up? Here, it shows up here. Here's what we're going to do. And then we're going to have, yep. Just like this. And me with my obsession with punch cards, I'm going to make sure that everything fits into 80 columns. And then here, yeah, that's not, and then here, start. like that. Okay. So now here, when I'm getting the statement list, what I should do is I should actually ask the context for the topmost scope frame. Oh, this is a little bit of an ugly way to do it, but it should work. Um, not back. Okay, now let's see here. Like this. Okay. Oh, this is ugly, ugly, ugly. First of all, this exposes an error, I believe, in my original implementation. Because down here, I'm moving statements nodes, but I also store a new one on here. But statements nodes is the pointer. Okay, that's right. And so statement node is the pointer to the uh, uh, oh, this is going to be ugly. Oh, so ugly. Unlike every single other thing, parse sequence is going to have to take the actual node it's supposed to be parsing into. Oh, how ugly. Uh, uh, indeed. And it's going to have to be AST pointer. No, 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 no. Uh, oh, how terrible. And here I'm not going to look at block stack back. What I'm going to do here Yes. There, like this. And then all of this is going to be shift tabbed. Don't have this anymore. And okay. So unlike every single other thing, yep. And then I'm going to have to change the signature for parse sequence over here and parser of HPP. And there, that should fix this. And this will have to be parse new scope. And I'm also going to have to put here like this. And oh, hug. Oh, I put this in the wrong spot. There. Now it's in the right spot. And parse new scope should then go up here. There we go. All right. So there is still a problem here, but it's a problem that only happens on parse failure, which is that this statement node, this will disappear. Except it won't. It can't. Oh, this is the source of a interesting issue that I noticed. Parse sequence can never fail. Ah, that's funny. Because a sequence can be empty, and so parse sequence can never fail. Um, but there's still going to be a problem when this pointer may eventually get thrown away, because something will parse the sequence, and then it will get the sequence back, and then it will go and look, is the next thing a close brace? Oh, it's not a close brace. Well, something's wrong. And then it will die a terrible death. It will throw a parse error. And then a pointer to this thing will be sitting on the stack, on this frame stack. But yeah. On the other hand, this frame stack will be popped. Like, it should be okay. It should be okay. But it's by the skin of my teeth that it's okay. The thing that I'm worried about here is that this frame stack here has a dangling pointer on it for a little while when there's a parse failure. Now, here when we have parse statement, this is going to be parse new scope. There we go. See, in this case, oh, it wasn't a closed curly brace. Ah, blah, throw up your arms. And which of course means that this nice pointer, this statement pointer here, will be destroyed at this return statement. And so this pointer being destroyed means that the statement that's being pointed at was destroyed, which means that the thing that's on this scope stack here will also be destroyed. Well, this thing on the scope stack is going to be there for a little while until it pops up, until it gets here and it gets popped off. And so there's going to be a brief period of time while it's throwing the error when there's going to be a dangling pointer on the scope stack until it's popped off. And I think that that's going to be okay in all cases, but it's a thing to keep in mind. And it's one of the dangers of storing raw pointers on things, because that's what I'm doing here. It's a raw pointer. Couldn't do it in Rust. uh, Now, I don't know what you would do. Actually, I got some suggestions about what to do in Rust, and it's just ridiculous, actually, what you would do in Rust to handle that. But that's a project I might undertake, actually, is rewriting this in Rust, just to learn Rust so that I can complain about it more articulately. Okay, so now we're going to look for other instances of parse sequence. And here, parse new scope. Nope, that's right. Aha. So I've replaced them all now. Good. Okay. So let's run the tests and find out whether all the tests work, because the changes I make should not have caused any of the tests to fail. At least if I didn't make any other changes that broke anything. But what did I change that would have caused this to fail? Oh, this is inside parse vardecal, and I see I need the identifier. I should be returning the identifier for the variable just declared. Oh my. Needs to be an optional is what it needs to be. Okay, so we're going to fix this. Oh, I have to fix it in parser.cpp. I have to fix it in here because that's where I put it. And it has to be not a bool. It's got to be an optional. Oh, what is the type that it needs to be? There's a place where I declare var idx here. Yes. Ah. There. All right. Declare var. And here I do there. There we go. So optional. How does optional work? Um, let's check. Because I think optional does actually define operator not. An operator bool. It has an and then. Ah, I should probably use has value rather than the cast a bool. And then here, there. All right. Oh, I didn't want that. Now let's try and run it. All right, all tests passed. So my transformation succeeded, which I'm pleased with. It's one of the nice things about having an extensive test suite is I can do this kind of thing where I kind of rip pieces apart and move them around and stuff, and then run the tests and they work. It succeeded. I did it. Um, so, uh, and I now have my commit hooks in, so I can do this commit. Uh, Yay! And I'm happy with my commit hooks. I have a goal with the commit hooks, which is to make sure that when I do this with Mercurial, that the summary all fits within 80 columns. And then that if I have more to the summary, that it ends with a dot, 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 and that all of these also fit within 80 columns. That is my rule for these. Now, there's this idea that you should have meaningful commit messages. And I don't think that can actually be enforced with a set of rules. I think that's actually one of the places where I think LLMs, in fact, are useful unequivocally, which is like you can have an LLM evaluate a commit message against the body of the commit and tell you whether the commit message meaningfully reflects what's in the commit in some way. Like you can tell it that even if the message is really succinct, it's acceptable just as long as a good developer could tell from the commit message approximately what the commit was about, and then have it evaluate. And that would be a good way to enforce meaningful commit messages. Because all the others, like, oh, it must have this format, or it must start with this thing with a colon and some other stuff, and must be this many characters and all of that. Like, it's just bureaucracy, right? It's just a set of rules that don't mean anything and won't guarantee you a high quality commit message. And not only that, but there are high quality commit messages that, in fact, probably don't follow those rules. So the whole thing is just dumb. Um, but an LLM might actually be able to intelligently apply the idea of high quality commit things. Okay, so now we're ready to actually implement the parse func declaration. Parse var decal, parse func declaration. Okay, now here we want to look at this. We want to look, what did we say in our BNF, what a function declaration looks like. What things did you implement into your toy language, Sir Elfman? Did you, I mean, it has a JIT, which is a pretty nice feature. Does it have data types? Does it have compound data types like structs? Does it support member functions on the structs? Is it object oriented? Does it have pointers? I'm curious to know. I presume it has functions, because if it's complicated enough for you to be for it to be worth writing a JIT for, then almost certainly at least has functions. Um, let's see, what's a function declaration look like? First of all, if start equals finished, and keyword well, yeah, there should be a func. I What the heck? I thought I had that in tokens already. Oh no, silly thing. Yeah, there, def. You know, I could probably have told that from looking here. Yes, def. Uh, so we grab this, grab the keyword. Uh, if we didn't get a keyword, or if the keyword must be, we must have, uh, the next token must be a keyword, and the kind of keyword it must be def. And if that's not true, then nope, it's not a function definition, not function declaration. Okay. All right. Now, okay, now we check again. Uh, now we check. Is it an identifier? The next thing that we see is it an identifier? Not identifier. And this is what variable declarations look like too. Oh, no, we're not. Nope. We aren't parsing an identifier here because parse identifier implies that we already know about the identifier. In this particular case, we do not. So that's not the right thing to be doing here. We need to here be checking to find out whether the next token is an identifier. So if auto const star, yep. Oh, what did I do in vardecal here? Ah, I actually care about it, and so and yes. There. Now, I wait until I've parsed the entire thing before I call it declared. That is almost acceptable. There is one problem. I have to declare it before I start parsing the function body. The reason why I have to declare it before parsing the function body is that I want to allow recursive functions. And so the name of the function has to be able to be looked up from inside the function body, which means that the name has to exist. But we can do that. Now, um, I'm going to have to parse the identifier list by hand here. This is all going to be tokens. I want identifier tokens. I don't want any expressions or anything like that. I want just identifier tokens. That's it. Just names. At some point in time, they might be type things, but that's going to be a future iteration of the language. Oh, you've gone off and aren't paying attention anymore. I'll type it in chat. Um, is your language? Yes, I have a laptop off to the side where I can type things. Uh, hmm. Well, that's interesting. All right. Let's see here. As I said, so we're going to have to go token by token for this, and I'm going to have to parse the list by hand. Uh, Indeed. So if we didn't see an open parent, and we also die. Uh, oh, there. So start equals finished, not equal to finished, then this. Otherwise, haha. Okay, no, because we may or may not have an argument. Oh, this is a little bit tricky. Um, no, there we go. Actually, here. Is that how that works? Ah, yes. Okay, and that's at column 67, so that's okay. Oh well. So if we see an identifier, then we can place back arg. There we go. And then I believe punctuator. No, we don't want this. What we want. And that's too long, way too long. That's, where's this? This is at 69. No, no, no. And still too long. There we go. There. All right. Keep on typing command instead of comma. All right. Then we say found comma. Oh, All right. If and we want not here. And here we want like this, like that. This. Okay. So now if we haven't found a close parent, all right. And this do statement here is not necessary. And here we actually want this. So we didn't see an identifier. And the next thing we check for is a close parent. But if we did see an identifier, then we look to find if there is a comma. If we did find a comma, then while we found a comma, we grab an identifier. Move to the next thing and see if it's an identifier. If it's an identifier, we put it on our list. Otherwise, we complain because the next thing should be an identifier after the comma. And if it isn't, something's wrong. Then we move to the next thing, we check. The next thing is the end, that's bad. But if the next thing is a comma, that's great, and we should go to the next. But if it's not a comma, um, then we should drop out. And if it wasn't comma, then means the next thing should a close paren. So then that's great. Okay. Um, now we're still not done. Uh, right? Uh, Not quite. First, we do one last check. Yep, that's what we want. Check if it's a brace. Nope. Then what we do here what we do is not parse new scope. What we do here is let's look and find out what does parse new scope do, because we need to do part of what parse new scope does, but different. because we need to create the scope ourselves. So first of all, we have a CTX, right? Declare var. Oh my. Um, so here we have declare var. Uh, uh, okay. Then we have to yes, like this. Make unique. All right, that is the right thing to do here. Now we say uh, scope frame and not var idx dot value. But context, so scope frame needs a context and not var idx dot value, but slist. Address of slist. There we go. Okay. Now we can say parse sequence. And the sequence is going to be no, 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 no. Yeah, like that. All right. Um, I think that's how this works, right? If we look here at how this works, parse while, we don't care about parse while or parse var decal. We care about parse statement, parse sequence, parse new scope. That's what we care about. So we made our new node. Then we made our frame. Oh, uh, then what does parse new scope do? Then it does this. And actually, and then what we do here is there. Okay, so this is not quite right. And in fact, this is not right at all, actually. This is, we should be, did I declare a new type for function, func declar? Oh my. Yes. Identifier. What is an identifier these days? So here, this is not what we want. Here, what we want here is, in fact, yes, not star S list, address S list. Yes. And the next thing we want is we want move and then body. And then like that. Var decal. Oh, there. That should be about right. All right. Anyway, I have another engagement now. And so I shall bid you all, my marvelous viewers, my many viewers, I shall bid you all a good night. And there's still more to do here. So, yep. I don't know if this will compile. Even if it does compile, it's not quite right um, because I need to declare all the parameters as variables within this scope. So I will do that. I also need to set the value of the function that I just made to this thing that I just made. So it's going to be interesting because that's another uh, that the last bit here, the set variable for function to point at function somehow is going to be that's going to be a trick. So we'll have to see about how to do that later. Anyway, as I said, we're done now. Going to end the stream. It's been marvelous having you all around. I wish I could have learned a little bit more about your programming language, uh, Mr. Elfman. Oh, I just realized that my face isn't here. Oops, I forgot to bring my face back. How terrible. Anyway,